Calculus 1, BSIE 1A, Charlie Team. Before we formally start this video, I encourage everyone to stay relaxed, have focus, and let us learn more. When deriving, we usually deal with equation in terms of one variable, such as y is equal to 3x raised to 4 plus 5x cubed plus 10x squared. But what are we going to do if the equation has two variables, such as x squared plus y squared is equal to 25? How are we going to differentiate such equation? Now this is where implicit differentiation comes in. With our given equation x squared plus y squared is equal to 25, we know that we can differentiate it by simplifying the equation in terms of x. So we have y is equal to negative square root of x squared plus 25. But sometimes this is time-consuming, difficult, and somehow impossible. Now, implicit differentiation is a technique in which allows us to differentiate with respect to a specific variable such as x, rather than solving one variable in terms of another. So in this given x squared plus y squared is equal to 25, we no longer have to simplify it since it's time-consuming. Rather, we will use implicit differentiation in order to differentiate or find its derivative. Now, in applying implicit differentiation, we are going to use the chain rule. The chain rule enables us to differentiate y with greater respect to x. Now, the chain rule is the derivative of a composite function is equal to the derivative of the outside function multiplied by the derivative of the inside function. So in every equation, we will treat y as another function and differentiate it with respect to x. Alright, now for better understanding, let's proceed to the examples. Alright, now we have our first example, which is x squared plus y squared is equal to 25. So the first thing that we're going to do in implicit differentiation is get the derivative of both sides. So we have d over dx of x squared plus y squared is equal to d over dx of 25. Now, we are using d over dx in order to tell us that we are differentiating with respect to x. Now, we know that the derivative of sum is just the sum of derivatives, so let us rearrange things and evaluate. So we have d over dx of x squared plus d over dx of y squared is equal to. Now we know that the derivative of a constant is 0, so therefore it's equal to 0. Now let us first get the derivative of x squared. Now in getting the derivative of x squared, we use the power rule. So the power rule is the derivative of x raised to n is equal to nx raised to n minus 1. So we're going to bring down the exponent and deduct it with 1. So in that part, we know that the derivative of x squared is simply 2x. Now in getting the derivative of y squared with respect to x, we are going to use the chain rule. Now, the chain rule states that the derivative of a composite function is equal to the derivative of the outside function multiplied by the derivative of the inside function. So in this part, we are going to treat y as another function and derive it in terms of x. Therefore, the derivative of y squared is 2y. So with the chain rule, we are going to treat y as the inside function and derive it with respect to x. So that derivative of the inside function is dy over dx, and that's equal to 0. So what are we going to do is we're going to transfer the expression or the function without dy over dx on it. So we have 2y dy over dx is equal to negative 2x. So what we're going to do next is to divide both sides by 2y so that we are left with dy over dx, since we want dy over dx. So we divide both sides by 2y, and we're going to cancel the 2y from the other side. So we're left with dy over dx is equal to negative x over y. So that's our final answer. Alright, now let's proceed to our second example. So we have 2x cubed plus 8y squared is equal to 38. Now we know what to do. First, we are going to get the derivative of both sides. So we have d over dx of 2x cubed plus 8y squared is equal to d over dx of 38. Now, as we all can remember, that the derivatives of sum is just the sum of derivatives. So let's just arrange things. So we have d over dx of 2x cubed plus d over dx of 8y squared is equal to, again, we know that the derivative of constant is just 0, so it's equal to 0. Now let's first get the derivative of 2x cubed. Now we know in getting the derivative of 2x cubed is we're going to use the power rule, in which all of us are familiar of. So we have the derivative of x raised to n is equal to n x raised to n minus 1. So we know that the derivative of 2x cubed is just 6x squared. So we have 6x squared there. Now in getting the derivative of 8y squared, we know that we are going to use the chain rule. Alright, so again, the chain rule states that the derivative of the composite function is equal to the derivative of the outside function multiplied by the derivative of the inside function. So again, in this part, we are going to treat y as the inside function and derive it with respect to x. So therefore, the derivative of 8y squared is 16y. Since 8y squared is our outside function, so we have 16y, and then our inside function is y, and we're going to differentiate it in terms of x. So that derivative of the inside function would be, again, dy over dx, and equal to 0. So just like our first example, we are going to move to the other side the function without dy over dx on it. So we are left with 16y dy over dx is equal to negative 6x squared. So what we're going to do is we're going to divide both sides by 16y because we want to be left with dy over dx. So we cancel 16y and we are left with dy over dx is equal to negative 6x squared over 16y. So as we can see from the numbers, there is a specific number in which we can factor out, and that is 2. So we are going to factor out do in this equation in order to simplify. So let's factor out 2. So we are left with dy over dx is equal to 3x squared. Well, that was actually negative. So we have negative 3x squared over 8y, and hence that is our final answer. Okay, so we're down to another video. But before we proceed, you can actually pause this video and try answering this one. Okay, so now we're back. So what we're going to do first is, again, let's get the derivative of both sides. So we have d over dx of x cubed plus y cubed is equal to the derivative of 6xy. So we know again that the derivatives of sum is just the sum of derivatives. So let's arrange things. We have d over dx of x cubed plus d over dx of y cubed is equal to. So in getting the derivative of 6xy, we are going to use the product rule. And the product rule states that the derivative of u multiplied by v is equal to u multiplied by the derivative of v plus v multiplied by the derivative of u. So in the given 6xy, we have 6x is our u, and we have y is our v. So again, using the product rule, we have 6x multiplied by the derivative of v. So the derivative of y is just dy over dx, since we are deriving y again with respect to x, plus our v right here is y, so that would be plus y times the derivative of 6x. Now we know that the derivative of 6x is just 6. Okay, so let us rearrange things and continue to evaluate. So first, let's get the derivative of x cubed. Now we know that in getting the derivative of x cubed, again, we're going to use that power rule. So we have 3x squared. And again, when deriving y, we will derive y with respect to x. We are going to use the chain rule, which is the derivative of the outside function multiplied by the derivative of the inside function. So we are going to treat y as the inside function and derive it in terms of x. So first, let's get the derivative of the outside function of y cubed. So that would be plus 3y squared multiplied by the inside function y, the derivative of the inside function. We have dy over dx is equal to 6x dy over dx, and y times 6 is just 6y. So what are we going to do in this part is to arrange things. So we are going to join those functions with dy over dx on them. So we've got 3y squared dy over dx minus 6x dy over dx is equal to 6y minus 3x squared. We did this in order so that we can factor out dy over dx and simplify. So let's factor out dy over dx. So we're left with 3y squared minus 6x is equal to 6y minus 3x squared. Now, in order to simplify and be left with dy over dx, let's divide both sides by 3y squared minus 6x. So let's divide both sides. And let's cancel the 3y squared minus 6x on the other side. So here we are left with dy over dx is equal to 6y minus 3x squared over 3y squared minus 6x. And if you look closely to the numbers, we can factor out 3. So right now, let's factor out 3. So factoring out 3, we are left with 2y minus x squared. And factoring out 3 in the denominator, we are also left with y squared minus 2x. So let's cancel 3. And we are left with dy over dx is equal to 2y minus x squared over y squared minus 2x. And that's our final answer. How did you do? Did you get this one right? So without any much further ado, we are left with another example, this time involving trigonometric functions. We have 4 cosine of x multiplied by sine of y is equal to 1. So before we start differentiating, or before we start getting the derivative of both sides, let us first simplify this equation by dividing both sides by 4. So let's cancel 4 on that side. So we are now left with much simpler equation. We have cosine of x sine y is equal to 1/4. So right now, let's proceed with getting the derivative of both sides, which we always do. So let's get the derivative of the right side. So we have d over dx cosine of x sine y is equal to d over dx of 1/4. Now, in getting the derivative of cosine of x sine y, we know that we are going to use the product rule, which states that the derivative of u times v is equal to u multiplied by the derivative of v plus v multiplied by the derivative of u. Now, with involving the trigonometric functions, we also need to know the derivative of the given functions. So we have the derivative of sine u is equal to cosine u multiplied by the derivative of u. And the derivative of cosine u is equal to negative sine u multiplied by the derivative of u. So since we have known this, we can answer this one. First, we have cosine x. Cosine x will be our u, and sine y would be our v. So with our product rule, we know that our u is cosine x, so we will write cosine of x. Now, we are going to get the derivative of our v, which is sine y, and we know the derivative of sine is cosine. So we will multiply it with cosine y multiplied by the derivative of y with respect to x, of course. So the derivative of y, we all know that it's dy over dx. With proceeding with our product rule, so that would be plus our v, which is sine y multiplied by the derivative of our u. So our u here is cosine, and the derivative of cosine is negative sine of x. Now since our u in this part is just x and the derivative of x is 1, so we no longer have to write it, is equal to the derivative constant 0. So right now let's simplify this equation. So we have cosine of x, cosine y dy over dx minus sine x sine y is equal to 0. So right now we are going to transfer negative sine x sine y to the other side in order to simplify. So right now we are left with cosine of x, cosine of y, dy over dx is equal to sine x sine y. In order to simplify, let us divide both sides by cosine of x, cosine of y, so that we will be left with dy over dx. And let us cancel cosine of x, cosine of y on the other side. Now, as we can see, that the given answer is involving the quotient trigonometric identities of tangent. So we can write our final answer as tangent of x, since sine over cosine is tangent. So we have tangent of x, tangent y. And hence, that is our final answer. Okay, so now we are down to our last example, still involving trigonometric functions, but this one is a little bit more complex. So the first thing that we'll always do is get the derivative of both sides. So we have d over dx sine of xy is equal to d over dx of x plus y. So as we can see in this part, we are using trigonometric functions, and we know that the derivative of sine is cosine u multiplied by du over dx. So let's just write cosine of x y. So in this part, the u of sine is xy. So since we have xy, we know that it will involve the use of product rule. So in this part, we have x as our u, and we have y as our v. So that would be cosine xy multiplied by u, our x, derivative of our v, which is y. So we know that the derivative of y in terms of x, or with respect to x rather, is dy over dx. And that's plus v. Our v here is y multiplied by the derivative of u, which is x, and the derivative of x is just 1. So let's proceed to the another side. So we know that this one is just the derivative of sum is the sum of derivatives. So we have the derivative of x is 1 plus the derivative of y, which is dy over dx, as we are deriving it with respect to x. Now let us simplify. Let us just use the distribution method. So we have here x cosine of xy dy over dx plus y cosine of xy is equal to 1 plus dy over dx. So in order to simplify, we are going to join the functions with dy over dx on them and transfer those who do not have on the other side. So right now we are left with x cosine of xy dy over dx minus dy over dx is equal to 1 minus y cosine of xy. So we did this in order to factor out, so that we can factor out rather dy over dx. So right now, let us factor out dy over dx on this part in order for us to simplify. So right now we are left with x cosine of xy minus 1. Alright, that was minus 1 is equal to 1 minus y cosine of xy. So in order to simplify, let us divide both sides by x cosine of xy minus 1. So in this part, we can cancel x cosine of xy minus 1 on the other side. So we are left with dy over dx is equal to 1 minus y cosine of xy over x cosine of xy minus 1. And that, my friend, is our final answer. And that is the end of this video. Thank you so much for watching, and I hope that you had a great time and learned a lot from watching. Please don't forget to subscribe to our channel.